a brass cube that is 6 inches on side and weighs 67 pounds. So we want to hold this cube in equilibrium underwater, and then the specific weight of water is 62.4 pounds per cubic foot, and its viscosity is 2.73 times 10 to the negative 5 pounds-second per foot squared. By adding a light foam buoy to it, and if the foam buoy has a specific weight of 4.5 pounds per cubic foot, what's the minimum volume required for the buoy? I've given this as a test question a couple times, and I really like it, and it's actually not as complex as your first reading is. I know people get intimidated by it, but it's okay. Let's just take a look at it and see what we can do. First thing we need to do is we need to draw a free body diagram. So I'm going to draw my surface of my water. There's my little brass cube. There's my foam that I'm putting at the top of it. I don't know why I got a little spike there. Now the important thing for this problem is to properly put down the forces. So we have a force of buoyancy on the foam. We also have a force of mass, so a weight of the foam. We have the weight of the brass. Now, where I found that a lot of people made a mistake on this problem is they forgot that even though the brass would sink, there is a force of buoyancy on the brass. So now if I go and let's do, okay, well, I'm going to sum the forces in the y direction. Up's going to be positive. That has to equal 0 to have it work out to be in equilibrium. And so what do we have? Well, we've got the force of buoyancy of the foam plus the force of buoyancy of the brass pushing up minus the weight of the foam minus the weight of the brass. And so at this point, we can start putting things together. So the force of buoyancy of the foam. Well, we got to remember force of buoyancy is the specific weight of the fluid times the volume submerged. So if we go about this, the force of buoyancy on the foam is going to be the specific weight of the fluid, and the fluid we're displacing is the water, 64 pounds per cubic foot. We have to multiply it by the volume that's submerged. Well, and that's going to be the volume of the foam, which we don't know. That's what we're trying to figure out. So now we've got the force of buoyancy on the brass. So the force of buoyancy on the brass is still going to be 62.4 pounds per cubic foot because we're looking at the fluid that's being displaced. And actually, we can write this a little bit simpler. As I've always said, we should really put the numbers in last. So if we go back and say, okay, well, it's the gamma of the water plus the volume of the foam times the gamma of the water times the volume of the brass minus, well, the weight of the foam. What's the weight of the foam going to be? Well, it's going to be the specific weight of the foam times the volume of the foam. And then we need to add to that, or subtract also the weight of the brass. And we know the weight of the brass is 67 pounds of force. So as I look at this, I know the volume of the brass because it's just 6 cubed. I know the specific weight of the foam. So all I'm left with is the volume of the foam, which is what we're trying to find. So let's go and start plugging our numbers in. Now I could put all this together because I've got the H2O here and pull out the H2O here, but we're going to have to divide by that at some point, so let's not worry about that. So the gamma of H2O, 62.4 pounds per cubic foot times the volume of the foam plus 62.4 pounds per cubic foot, the volume of the brass. What's the brass? Well, the brass is 6 inches on side, and it's a cube, so we're going to multiply, we're going to raise that to the third power. I want to put that into cubic feet, because everything else is in cubic feet. So what am I going to do? I'm going to say, well, I've got 1 foot, it's 12 inches. I'm going to cube that, because I need cubic. So that will give me the buoyant force of the brass cube itself. And then we're going to subtract from that the specific weight of the foam, 4.5 pounds per foot cubed, times the volume of the foam, which we don't know, minus 67 pounds. And so what I can do is I can isolate my variables. So since this all has to equal 0, I can bring over that term, which is a number, and that term is a number to the left-hand side, and then I can divide through, I can bring out my volume of the foam and divide everything through. So once I do that, so I just solved this equation for the volume of the foam. What I should be getting is 1.02 cubic feet of foam. One equation, one unknown.